In the previous video, we learned about the command git reset together with its three modes, --soft, --mixed, and --hard. We then applied our knowledge to a few Gitsasters and saw that by understanding Git and how it works, we can feel confident in fixing cases where we need to rewrite history. In this video, we'll acquire additional tools to rewrite history and deal with Gitsasters. Please make sure to watch the previous video before this one, as we covered relevant background there. So to get started, let us create a small repository to play with. Okay, and let's create a file, 1.txt with the content of hello. So where is it now? It's in the working directory, yet it is untracked, as Git never included this file in its index. So if I use git status now, I can see that it's untracked. Cool. So let's stage this file, add it to the index by using git add. So where is it now? It's in the working dir as well as the index. How can we verify that? We'll simply use git status again. Cool, so we can see it's under the changes to be committed section. And now we can just create a commit. So git commit, we'll give it the message of commit 1. This would be the nickname for this commit for us. So now it's in the repo as well. And if we use git status, we're on branch main and there is nothing to commit. Working tree clean, because the working tree is the same as the index, which is the same as the last commit in the repository. And we can use git log to see that we have actually created a commit object with a message commit 1. Great. So now let us create another branch and make some changes there. So for that, I'm going to use git checkout -b. This creates the branch and switches to that branch, and we'll call it feature branch. So again, note that git checkout -b creates the branch feature branch and then also changes head to point to this branch. Now, let's create a file. So I'll echo introducing a feature branch into a file called a.txt, and I'm going to stage this file and commit it. I'll call this commit2.0. Cool. Let us go back to main. And now I'll change 1.txt. So I'll just echo change and it to 1.txt. So now 1.txt looks like so. And I'm going to stage those changes and commit them. So this would be commit 3. Oh, wait, actually, I wanted this change to be introduced in the feature branch and not in main. Oops. We actually dealt with a similar case in the previous video where we accidentally committed to the main branch, but then we wanted the commit to be recorded on a new branch. Now we want it to be on an already existing branch. So what should we do? Well, as we saw in the previous video, it is useful to draw the current state versus the desired state. So let's start with the current state. Here, the relevant commit 3.0, is on the main branch. And in the desired state, there are technically a few changes. First of all, the commit which main points to is commit 1. Second, commit 3 points to commit 2. And third, the feature branch points to commit 3. So let us start by adding the changes introduced in commit 3 to feature branch. So let us look at the changes this commit introduced. So I'm going to use git diff for that, git diff, and I'm going to look at the difference between the parent of head to head. So this is exactly what commit 3.0 introduced. And I would like to apply these changes to the last commit on feature branch. So for that, we need to be in feature branch. So let's check out feature branch. So I'm going to use git cherry pick command like so, git cherry pick, and then I need the SHA-1 value of commit 3. I have it right here. So git cherry pick this commit. Cool. So this basically takes the changes in commit 3.0 that we saw here In this case, it's changes to the file 1.txt. And then Git cherry pick generates a new commit, including these specific changes. And then it also changes the pointer of the active branch, in this case, feature branch, to point to the new commit. So if we look at the log now, git log, we can see that we're on feature branch and we have commit 3.0. So if we observe the changes it introduced, so again, I'll look at the diff between head tilde1, that is commit 2, and head, that is commit 3, I can see that this is exactly what we wanted. We applied the same changes that we had seen earlier, and this time we apply them on feature branch. So now our newly created commit points to commit 2 as desired, and also feature branch points to this new commit. What is left for us to do is to change main to point to commit 1. For that, we can simply switch to main branch again. So git checkout main. And now undo the last commit on this branch. As we learned in the previous video, we can just do that using git reset --hard head tilde1. Again, if you're not sure about git reset, please watch the previous video where we covered this in detail with many examples. Awesome. So we were able to achieve the desired state with the power of the well-known git reset command, together with a new command we introduced, git cherry pick. Cool. So now let's look at another example. So let's create yet another file, echo my new file into 2.txt. We don't have a file with that name yet. Let's stage it and commit our changes. Call it commit 4. Good. And let's add some content to it. So echo more text into 2.txt. And now let's say I even commit this. Let's call this commit 5. Let's say I even push this to the remote repository. I won't do it now, but let's say that we did. And oh, oops, I actually had a typo there, right? I wrote test instead of text. So I want to fix that. With what we have already learned, we know we can use git reset of some sort to undo this last commit, right? The problem is that it has already been pushed to the remote. This means that someone might have already git pulled this commit, and we don't want to rewrite history so that it is inconsistent between our copy of the repository and someone else's copy of the repository. In other words, we shouldn't use git reset to rewrite commits that have already been pushed to the remote unless we're completely sure that no one else has pulled the relevant commits. So what should we do? Well, basically, we should create another commit that will undo the last commit. Obviously, in this case, we can also just change the contents of 2.txt, but we want to clarify that we're undoing the last commit as it was a mistake. So what we want to do is to take the changes introduced in the last commit, which again, we can see by using git diff head tilde1 head. And actually we want to apply them in reverse like so. So we can look at the difference between head and the parent of head. So instead of adding this line, we want to remove this line. So in this case, we added a new line in our commit and we will erase it. If we introduce a commit where we remove the line, we'll need to add it again to undo the faulty commit. So to do just that, we can use Git Revert. So this command reverses the changes that previous commits introduced and records them in new commits. So in this simple example, we can just use Git Revert and head. Now this tells Git to take the changes introduced at head, which before running this command points to commit 5.0, and reverse those changes. So let's clear up some space and let's git revert head. And now we're being asked to give some message. So revert commit 5.0 is okay. Cool. And if we use git log, we can see that the new commit has been introduced. And let us look at the changes it introduced. So let's look at the difference between the parent of this commit, that is commit 5.0, and the latest commit. And we can see that this commit did exactly the reverse of the previous commit. So it's the same as running git diff head -2, that is the parent of head, and the parent of head. So this was the reverse of this commit, of those changes. By the way, we can also use git show to show us the changes introduced in a specific commit. So instead of using git diff head -1, that is the parent of head and head, I can just use git show head, which is basically the same. Of course, it also shows me some additional data, such as the author of this commit and the message of this commit, but the changes are the same. Indeed, this is the reverse of the previous commit, that is git show head -1 in this case. Cool. So now we've seen two new commands, Git Revert and Git Cherry Pick. Now let's see a more advanced case. Let's say I introduced a commit that worked really hard to create. So let's echo a lot of work into one.txt, and I'm going to stage this change and commit it. Cool. So obviously this wasn't really a lot of work, just to save you precious time from seeing me type a lot of content. But let's say it's a really important commit that I worked really hard to create. Now say that I was very hasty and by mistake, I executed this command, git reset hard head -1. Oh my, what a Gitsaster. Okay, so I cleared up some space here. As you should recall from the previous video, git reset first goes through the soft step, that is changing whatever head was pointing to, in our case, the main branch, to point to what used to be the parent of head, that is, in our case, the commit that reverted commit 5.0. So this is where git reset -- soft would stop. We can see that this is indeed the state by using git log. So indeed, we see that head is pointing to main, which in turn points to the commit that reverted commit 5.0. Next, git reset updates the index to be the same as what head currently points to after the first step. So in our example, the index no longer includes the changes introduced to one.txt, and this is where git reset -- mix would stop. In the third step, git reset updates the working dir to be like the index. So in this case, it means the working dir will no longer include the changes we introduced to the file one.txt. We can verify that if we use git status. And indeed, we see that nothing to commit. The working tree is clean. That is, it's just the same as the index. And also, we can look directly at the file system. So in this case, let's look at the content of one.txt. And it doesn't include all of our precious hard work. So our precious changes are gone. Or are they? Are they actually gone? So as we know, the commit object representing commit 6.0 was introduced to the system. So the git commit object is recorded within Git's internal object database. As we learned in previous videos, this commit object references a tree object, which will in turn have a reference to the blob with the updated contents of one.txt. So if we have the SHA-1 of commit 6.0, we can actually look at it. Let's validate that. Okay, so let's say that in some magical way, I was able to get the SHA-1 value of commit 6.0. So we can now look at it using git show. And indeed, we can find and look at this commit and the changes it introduced. So the commit is there. And actually, this commit's parent is still commit 5.0. So basically, all we need to do is just to have head point to commit 6.0 again. And for that, we can use the same command, git reset -- hard, and provide it with this SHA value. Again, this command first update whatever head is pointing to, in this case, the branch main, to point to commit 6.0. So let us verify that with git log. Cool, we can see that indeed main points to commit 6.0. Then git reset updates the index to resemble the state of commit 6.0. and then also updates the working dir. So let us quickly verify that. So git status is supposed to be clean. Cool. And let us look at the contents of 1.txt. Awesome. So now let us remove this commit from the history yet again. Git reset hard head -1. So back to git log. Commit 6.0 is no longer in our log. So we completely undid commit 6.0 and head points to main, which in turn points to the commit reverting commit 5.0. And also the staging area and the working dir match the state of commit that reversed commit 5.0. So git status, and let's look at the content of 1.txt. It doesn't include our precious work. So now let's say we don't have the SHA-1 value of commit 6.0. Are we lost? Well, luckily, no. This is time to introduce yet another important tool, Git Reflog. So basically, while working and without needing to do anything, Git silently record what head points to every time we change it. So whenever we change a branch, so we switch between branches or we introduce a new commit or use git reset, Git updates its reflog. So let's look at it, Git Reflog. Okay, we can see here the SHA-1 of our last commit, commit 6.0, right here, moving to this SHA-1, as we can see here. To get a better view of these commits, we can use git log -g, which gives us a normal git log output, but for our reflog. So let's try. This indeed looks just like git log, right? But it also has a reflog here. So it has here, for example, head @0 wrapped by squared brackets and the reflog message, and then also the data of this commit, so the metadata, the author and the date and the message and so on. Cool. So using Git Reflog, we're able to find the commit SHA of commit 6.0, and we can now use git reset --hard as we've done earlier. As an alternative, we can create a branch pointing to this SHA-1 value like so. So let's use git checkout -b, new branch, and give it the SHA value of commit 6.0. So let us remove our commit again. And now let's consider our reflog again. Cool. If we now look closely at the reflog, we can see that it also uses nicknames for our commits. So just as we could use head -1 to reference the parent of head, Git Reflog actually uses head @(1) to reference the last thing head pointed to. So instead of using git reset --hard and then the SHA-1 value, so we can reference this commit by its nickname like so, git reset --hard head @(1) like so. And we got to the same result, that is we're back at commit 6.0. Nice. So to sum up, in the previous video, we covered the command git reset together with its three modes: --soft, that moves whatever head is pointing to; --mix, that goes on to update the index to what head is pointing to after the soft step; and last, --hard, which updates the working dir to match the state of the index. In this video, we added three new tools to our toolbox. So first, we introduced Git cherry pick, which applies the changes introduced in a commit or a range of commits. Second, Git Revert, which reverses the changes introduced in a commit or a range of commits. And last, we looked at Git Reflog, which shows us the history of what head points to and comes in handy when we lost a commit. We applied our knowledge to various cases, including committing to the wrong branch, pushing faulty commits to the remote, and even losing a commit from our reachable history. All in all, you should now feel confident when facing a wide range of Gitsasters. The important thing is to understand that it's all pointers to commit objects that we already know and understand from our previous videos. When you're not sure, just draw the current state as well as the desired state, go over the tools we've covered here, and you will be on your way to success. Of course, if you have any questions, feel free to leave them in the comments below. Also, if you have any requests for additional videos I should create, please let me know as well. See you all in the next videos.